unfortunately. I'll try to do that later. All right, so on page 71, we are going to write, and these are your notes, what you choose to write, girls, or not, is up to you. But this histogram is perfectly symmetrical. Perfectly symmetrical. Which means it looks exactly the same to the right and to the left of the middle. Okay? I wish I could have a desk right here. If that is the case, the mean and the median will be the same. So if you have a graph of a histogram, can you guys read that at all? Wonder if I put it in yellow, if that would be better. The mean, how's that? Is that better? Okay. The mean and the median will be the same number. If you have a perfectly symmetrical histogram. Okay? So for this graph, what would my median and mean happen to be as you look at it?
7.
That's right. It's going to be right here, right down the middle, and that is 7. So your mean is equal to 7. That's your average. Your median is equal to 7. And we've talked about mode before. What's mode mean again? Bless you. Right. It's the one, it is a repeated number, hopefully. It's the one that occurs the most. So the mode occurs the most. So is this unimodal or bimodal? Unimodal, okay? Unit meaning one mode. This is unimodal. And when you have a unimodal symmetric graph, then the mode is also going to be the same. So the mode here is also 7. So if you have unimodal and symmetric, that means the mean is equal to the median, which is equal to the mode. Yes? Because you have just one spike or one highest column, like we do here. Because this is saying that we had more people that got, if this was like quiz scores, that got 7 out of 10 or 7 out of 11, I guess, maybe, then got 6 out of 11 or 8 or any other number. Good question. Let me make sure I did this.
Kind of don't like this.
You kind of do or don't? Well, gotta really get off the phone and like look up here then, right?
No, it's not an issue of me being receptive to it. It's just annoying.
Annoying? How so?
I don't know, like, who cares?
Who cares? Oh, well, I think it's good to know. It helps you in identifying characteristics of a graph very quickly, or it could.
How does it gonna help me when I'm rich?
Well, you'll be looking at your dollars and saying, oh, here's my average of what I took over the year. Here's my median. I don't know. I don't know. All right. Now, if you happen to have a graph like this, it is symmetric, okay? So this is a symmetric graph, which means that my mean is equal to my median. You guys see that very well? My mean and my median would be here in the middle. So there's my mean, equal to the median. But this is this unimodal? No. So your modes, how well does that show up? Not really. Your modes are right here at the high points. So here is a mode and here is a mode. Here's a mode, here's a mode. So we would say this graph is bimodal. Bimodal. Okay? What questions do you have about that first one? All right, let's take a look at the second one. Now, this happens to kind of look like that first picture we saw in the meme. Okay? It is skewed to the left. So whenever you have, I think, did I ever talk to you guys about the beaver tail or the tail of something, that means it is skewed in that direction? Yes? No? Never? I think I did too. I think I did, but maybe not. So this is the tail part. If you imagine this looking like some kind of rodent, like a mouse or a beaver or, I don't know, maybe a raccoon, okay? Whatever direction the tail is, that is the direction of the skew, what we say the skew of the graph. So this is skewed left, okay? If it is skewed left, the tail pulls the mean down. So if we were to try to guess where the mean and the median are, let's say the mean is going to be following and is distracted by the tail. They follow the tail. So the mean maybe is right here. And that's an approximation. I don't know exactly what the mean is right here. But it is definitely, in this case, less than the median. The median is like the girlfriend of the couple. She really doesn't care about the outlier, okay? And this is an approximation also. So, in this example, we are going to say for histograms or frequency graphs, Jamar, you might want to write some of this. For histograms or frequency graphs, the median will equally divide the shaded areas. Thank you. You all right? Which means you will have the same number of observations on each side of the median. This is page 71 that we're on, and I am recording it too. Okay, so this median, even though it is approximate, we're saying there's about half of the area here in purple over here, and there should be about half in purple on the other side. Okay? When you are talking about the median, you're talking about the area that is shaded below. You should have about half the area on both sides. Okay? And again, the mean will always follow the tail. Okay? All right, so mode. Can you tell a mode here in this problem? The one that occurs the most, the score that occurs the most, can you tell? Is there a bar that's higher than the other ones? Yeah. So your mode is right here at 9. That one we definitely can tell. Your mode is 9. Okay. This says, let's do this in blue. The small values of 1, 2, 3, 4, and 5 pull the mean or the average, pull the mean to the left, what does it say? To a value smaller, okay. Pull the mean to a value smaller than the median. Okay. All right. And the last part. There's one more part. So there's a lot of writing in here. When the graph is, I'm not going to write that. I'm just going to say when you have a unimodal graph, which means one mode, and it is skewed to the left, okay, then the mode is usually the largest number. Okay? So you would have the mean is less than the median, which is less than the mode, which is what you see here. Your mean is less than the median, which is less than the mode. Yes, Chris?
What's the underlying word say?
Usually. It's usually the largest. Okay? All right. And the last one. That is totally cut off. Yes, unimodal graph and skewed left. Then the mode is usually the largest number. And the mean is going to be less than the median, which is going to be less than the mode. And the last graph on that page says we are skewed to the right. So here's my tail. We are skewed to the right. Usually the largest number. So if I have my tail skewed to the right, what is my mean? My mean is going to follow that. Okay? So my mean, I'm going to say, is right here. My average is going to be here. And is my median going to be greater than the mean or less than, you think? Greater? Should be less than. The median does not care about these outliers. Think about that meme. The girlfriend does not care about that other pretty girl, okay? So here is my median over here. And can I tell the mode here? Can I tell what value people got most on the test or the quiz? Yeah, it's 3. So your mode is right here. And it is 3. So, similarly to the last one, the median is going to divide your areas in half. Okay, median, I'm going to do that in green. The median divides the shaded areas in half, meaning you should have to the right of the median, this area in yellow should be about the same as this area on the other side in blue. Okay, that's what the median does. It's the middle, so you should have equal amounts of area on both sides. Okay. Regarding the skewed to the right, let's see. A skewed right graph will pull the mean to a higher number than the median. So in this case, your numbers of 7, 8, 9, 10, and 11, there's not a lot of each of those. That's why it's skewed to the right. They are pulling the median to be higher. And the last thing I will say about this is if you have, again, a unimodal graph, which this is, then your, how do I want to say this? Greater than, or I want to say they're all less than? Greater than. Then your mean is going to be greater than your median, which is going to be greater than your mode most of the time. And that's when it is skewed to the right. So there's a lot of information on here. Will you have to kind of know this? Yeah, you're going to have to know if you see a histogram that is skewed to the right, that your mean is going to follow your outliers. So it's going to be mean is bigger than your median, which is going to be probably bigger than your mode. Okay? So yes, you are going to have to know these. Any questions on that for right now? That's a lot. All right, let's go to the next page. Page 72. So we're going to put this into practice right away. We're going to see if we can figure out what we know about these graphs that are here before us. Okay? So somebody give me one attribute, one thing you think you might know about this first histogram on page 72. It is symmetrical. It is perfectly symmetrical. Okay? Perfectly symmetrical. Good. What else do we know? Somebody else. Yes, go back and look at the page just before.
So that means the mean, oh,
Go ahead.
does that mean the mean million
R.
and are the same?
Yes. Yes. Because it's perfectly symmetrical, the mean is going to be equal to the median, which is also going to be equal to the mode. And the reason it's equal to the mode is because this one is specifically is unimodal. So if we had a bimodal graph, then it wouldn't necessarily be the mode equal to the mean and median. Now, I don't know if you can tell what the numbers are, but can you see what the mean, the median, and the mode would be in this graph? It's right here, which is 7. Yes. Okay. Is there anything else we can tell in this graph? I'm trying to think. Oh, you guys have something else at the top. I forgot. We'll come back to that in a minute. We'll talk about standard deviation in a minute. So I think that's pretty good. Any questions about that first one? Perfectly symmetrical, unimodal, the mean is equal to the median, which is equal to the mode. All right, let's take a look at the second histogram. Talk to me about this histogram. It is symmetrical. Is it perfectly symmetrical?
Yes.
Yes, it is. So again, this is perfectly symmetrical. What else do you notice? Somebody else. I appreciate it, but let's let somebody else.
I got you.
Okay.
Boom. The median is 5.
Okay, the median is 5.
Yes, it is.
Median is equal to 5. Because it's symmetrical, remember, that means you should have half to the right and half to the left. So I would agree with that. What else can you tell me? Who said that?
Me.
Yes, bimodal. What does that mean, bimodal? What does bi mean? 2. So it has 2 modes. What are my modes?
9 and 3.
That's right. Right here. That's a mode. This is a mode. And that is 3 and 9. Those are your modes. What else? Hello.
What did you say?
I said hello. Now, what else can we tell? What haven't we talked about yet?
Wait, if it's blue, if it's blue to the left or right?
Okay, is it skewed at all? Not if it's symmetrical. So you're right. It's not going to be skewed in either direction if it's symmetrical. We talked about the median. What about the mean? Where would the mean be in this perfectly symmetrical graph? Come on, Nicole, where would my mean be? Take a estimated guess. What happened? Come on, people. Where would my mean be? Thomas, where would my mean be? Help her out. Help me out. I don't know. Just just gonna draw. Oh, there.
Is it not 11 minus?
No, that you're thinking of range. My mean, when you have a symmetrical graph, is going to be the same as the median. Okay? So right here, mean and median are right here in the middle. That's my mean. Here's my median. Same thing. And they are both what? 6. 5. 6. That is a 6, isn't it? Did you say 6? Oh, okay.
Well, let's say 5 on here.
Yes, I was wrong. The numbers are a little small and not very sharp. That's what I'll blame it on. Okay, and it's not skewed, bimodal. I think we got that. All right, and let's take a look at the third one. Talk to me about this graph. Who haven't I talked to? Chris has talked. How about Callie? What can you tell me about that third graph? Huh? What? What?
I don't know, Dee.
I don't know either.
How was your grade?
It is symmetrical. It was all right. Perfectly symmetrical. What else? Somebody else. Ian, why don't you give me something? We're on the third graph. How many modes do I have? Say it again. 0 mode. I don't have any values that occur more than any other. What do you think, Marcellus? 2. Yeah, it's bimodal. And what are those modes? 1 and 11. Yes. So here's a mode. Here's a mode. 1 and 11. Okay. What about my mean and medians? Since it's perfectly symmetrical, where's it going to be? In the middle. Yes. Don't have to have any values there. But if you're finding the mean and you're finding the median, you have to have, for the median, the same amount of area on both sides. So here, the mean is equal to the median, which is equal to what value? 6. Yes. All right. Now, let's go back up to the top. Talk quickly about standard deviation. What is standard deviation again? I think I talked about it yesterday a little bit. A definition?
When like something out of the ordinary of the data happens?
No, that's outlier. I think you're thinking of outlier. Outliers are out. Yeah. Yes. Go ahead.
Is it like a percent of the data that's in?
It is a you're thinking of like specifically one standard deviation, yes. I'm going to say standard deviation in general is the spread of the data. The spread of the data. That's up at the very top, I think, of that page. How spread it is. So if I look at these 3 different pieces of data, and did I actually get up in front of you and do like big SD, big standard deviation, small standard deviation? So which of these has the smallest standard deviation? would you say? Graph number 1, 2, or 3? The smallest. You think number 3 has the smallest? You think it's more close together in the middle?
Number 1.
Yeah, I think it would be number 1. Okay? Because it's all bunched up together. So add that to your graph. This has the smallest standard deviation. And then looking at the other two, which of those two do you think has the largest standard deviation? Which is more spread out? Now you're like, well, Miss Thede, they both go from 1 to 11. Yeah, that's looking at range, but which of them are more spread out? Graph number 2 or graph number 3? 50-50 chance. 3, yes. So this one down here has the greatest or largest. This is the greatest standard deviation. Standard deviation. So how spread out is your data? Questions on that? Oh my gosh, what time is it? All right, very quickly, go to page 74. This is probably all we'll have time for. Oh my gosh, more histograms. Jamar. All right, so you see all these different histograms. Guess what? We do not have to put all the attributes down. Rude.
Oh, I'm sorry. I'm so sorry.
We do not have to put all the attributes down for all of these. Rather, it says for number 1 at the bottom, which histograms have a mean which is greater than its median? Which has a mean greater than its median? Okay, so look at those graphs. And what does that imply about the scores? Okay, look at these. Right now, everybody. Which has a mean? Remember, the mean always follows what? The tail, right? Or where it's skewed. The mean is going to follow the tail, and the median really doesn't care. So write down for number 1, which of these graphs do you think has a mean greater than the median? And when you look at these graphs, they go in order from left to right. They increase from left to right in values. Jamar?
Huh? That wasn't me.
Why does this
I'll give you a hint. There's 2.